Hello, good morning, students. So our today's topic is atoms. So based on this topic, you are going to get 2 to 3 marks in your Karnataka CET exam. Okay. So minimum 2 question at least it is fixed. So sometimes they are asking 3 questions also. So let us continue with the synopsis part. So based on the atoms, we have seen many of the models, right? So the first atomic model was proposed by J.J. Thomson. So the first atomic model was proposed by J.J. Thomson. So J.J. Thomson in year 1898, he will give one model for the atom. According to that, whatever the positively charged particles are there. So atomally in positively charged particles irutte, they are distributed throughout this orbit, they are distributed throughout this one, but negatively charged particles are embedded into this. The negatively charged particles are embedded into this like a watermelon seeds, so this J.J. Thomson model, it is also called as plum pudding model. Okay. Yes, so this is according to the J.J. Thomson model. We will just discuss how many models are there. Main other main points irutte adanna now discuss ಮಾಡ್ತಾ ಹೋಗೋಣ ಆಯ್ತಾ. So this is according to J.J. Thomson model. So J.J. Thomson model, what it will say, the positively charged particles are distributed throughout the atom and the negatively charged particles are embedded into that. Okay, so as we know that atom is nothing but what? It is the smallest particle of the or smallest particle of the given molecule, we can say, right? So here whatever the atom is there, this consists of, that is the positively charged particles and the negatively charged particles. The positively charged particles are called as protons and the negatively charged particles are called as electrons here, right? So whatever the protons, that is the protons are there, they are at the center of the nucleus, then they are around the nucleus, then the electrons are revolving around the nucleus here. In the orbit, the electrons are revolving. So this is the basic concept about the atom. But before that, this we know now, but before that, idkinta munche yavada atom model kottidare antandre. So the first model is J.J. Thomson, then the second model was given by the Rutherford here. So what this Rutherford will do here, he will obtain some of the concepts from the J.J. Thomson and he will perform the experiment that is called as alpha particle emission process, or the experiment here. So according to this experiment, what he will suggest, that is he will take a radioactive elements in and he will perform the experiment of alpha scattering particles to investigate the atomic structure. Okay, this experiment was later performed by the Hans Jaeger and Marsden. Hans Jaeger and Marsden. So Jaeger Marsden experiment is there, which was obtained from this Rutherford model. So what is this alpha scattering model or the Rutherford nuclear model? So what he will do, he will consider, he will take a screen and inside this screen, he will place one gold foil. He will place a gold foil here and here he will keep in front of that the source of the alpha particle. The source of the alpha particle. Source of the alpha particle antandrenu. From this source, the alpha particles are coming out. Yes. So when these alpha particles will come out, he will make an arrangement in such a way that it will go and hit the gold foil here. So when it will go and hit the gold foil, here the alpha particles will get scattered into different angles. The alpha particles will get scattered into different angles here. Okay, so this was the experiment. What is the conclusion of this experiment? According to the Rutherford, after this alpha scattering experiment, he will observe that the some particles will not get scattered. It will go without any deflection and the some particle will be reflected back and some particle will be getting scattered here. Here, these whatever the atoms are there, these are getting scattered with certain angle. They are getting scattered with certain angle. So this is what Rutherford alpha scattering model here. Okay. The number of scattered particles, how many the atoms will get scattered, the formula is given by n is inversely proportional to sine to the power of 4 theta by 2. How many electrons will get scattered here? That number of electrons will be calculated by using this formula. That is n is inversely proportional to sine to the power of 4 theta divided by 2. Suppose if you plot the graph between this number of atoms versus the angle theta here, the graph nature is, it is a curve like this. It is a curve like this. Okay. Then next, here Rutherford calculated the relation between the impact parameter and the scattering angle. Impact parameter and the scattering angle. So that impact parameter is given by B is equal to ZE square cot of theta divided by 2 whole divided by 4 pi square, 4 pi epsilon naught into EK. EK is the kinetic energy here. Okay, EK is the kinetic energy. So here we can substitute the value of theta and we can calculate the value of B here, that is impact parameter. Okay, so based on this we have the question. Later we will see that. Now you just note down, if you are sitting with the book, so ಈ formula na ನೀವು note down ಮಾಡ್ಕೊಳ್ಳಿ. The impact parameter and the angle of scattering is given by this relation. Yes, it is B is equal to ZE square cot of theta by 2 4 pi square 4 pi epsilon naught EK. So ಇಲ್ಲಿ terms ಅಂತೂ ನಿಮಗೆ ಗೊತ್ತಿದೆ. EK is the kinetic energy, Z is the atomic number, E is charge of the electron, theta ಏನಾಗುತ್ತೆ scattering angle ಆಗುತ್ತೆ, 4 pi epsilon naught it is constant. Yes. Okay. Then next. So what are the postulates of this Bohr's atomic model? So Bohr's scattering model anna navi discuss madidvi. So ಏನು ಅದರದ್ದು ಏನು outcome ಇದೆ? So according to this Bohr's atomic model, the outcome or the result is what? Here the positively charged particles are concentrated at the center of the atom. So this center is named as what? It is named as the nucleus. It is named as the nucleus here. Okay. And the electrons are situated in a large empty space around this nucleus. So first is what? That is the positively charged particles are concentrated at the center and that center is called as nucleus. Second postulate ಏನಾಗುತ್ತೆ? The electrons are situated in the empty space around this nucleus ಅಂತ ಹೇಳ್ತಾರೆ. That is the second postulate here. The third postulate is the atom is neutral because the number of positive charge is equal to the number of negative charge. So the Rutherford will say that the atom is neutral here, neutral in nature. So what is positively charged, negatively charged and the neutrally charged body here? ಪಾಸಿಟಿವ್ಲಿ ಚಾರ್ಜ್ಡ್ ಬಾಡಿ ಅಂತ ನೀವು ಹೇಳಿದ್ರೆ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, the charges whatever you are seeing, the number of positive charges will be more. If you are giving more number of negative charges, then the body is said to be negatively charged. If the body is having same number of protons and same number of electrons, then this is said to be neutral in nature. Okay, so these are the postulates of the Rutherford's model. Then the drawback, so why this theory will fail. So according to this, the electromagnetic theory, so according to Rutherford, the electromagnetic theory, any charge which is accelerated should radiate energy. ಹೌದಾ, ಇಲ್ಲಿ ಏನಂತ ಹೇಳ್ತಿದ್ದೆ ನಾನು, the electrons are revolving ಅಂತ ಹೇಳಿದ್ರೆ ಇಲ್ಲಿ energy, so for the motion ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, energy consume ಆಗ್ತಾ ಇದೆ. From where this energy will come? ಹೌದಾ, ಸೊ ಅದಕ್ಕೆ ಎನರ್ಜಿ ಇದ್ರೆ ಅದು ಮೂವ್ ಆಗ್ತಾ ಇದ್ದಾಗ ಅದು ಎನರ್ಜಿ ಲಾಸ್ ಆಗುತ್ತೆ. ಹೌದಾ, ದೆನ್ ವೈ ದಿಸ್ ಆಟಮ್ ದ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ರಿವಾಲ್ವಿಂಗ್ ಇನ್ ದ ಸೇಮ್ ಆರ್ಬಿಟ್, ಈ ತರ ಕ್ವಶನ್ಸ್ ಡೆವಲಪ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಸೊ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ರೀಸನ್ ಹಿಯರ್ ದ Rutherford theory will also fail. Okay, so the next Bohr's atomic model will come. So first J.J. Thomson, then Rutherford scattering model, then the Bohr atomic model. So before going for the Bohr atomic model, here we have some of the formulas. That is, electrons ನಮ್ದು circular orbit ಅಲ್ಲಿ ಮೂವ್ ಆಗ್ತಾ ಇದೆ. ಹೌದಾ, so when the object is moving in a circular orbit, ಯಾವ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇರುತ್ತೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ? If the object is moving in a circular motion, which force is acting on the body? Yes, Abhishek, Asha, Damini, Harshita, if the object is moving in a circular orbit, which force will be acting on that? Yes, in the chat box you can tell your answers. Yes, Sir, Rakshita, Shilpa, Harshita, so everyone has given the answer. That is centripetal force. Yes, so that is, if the object is moving in a circular orbit, the centripetal force will be acting on that. So as the charge we are considering here, so for the charge we have the Coulomb's law, that is 1/4 pi epsilon naught q1 into q2 divided by r square, which is equal to, that is our Coulomb force, that is a centripetal force. So centripetal force is given by mv square divided by r. ಹೌದಾ, ಸೊ ಇಲ್ಲಿ q1 q2 ನಾವು electron ಅಂತ ತಗೊಂಡಾಗ ಇಲ್ಲಿ ಏನಾಗಬಹುದು, electron ಅದ್ದು q1 into q2, it is nothing but it is becoming e square. ಹೌದಾ, so the charge of the q1 is e, charge of the q2 is also e, therefore it is becoming e square upon r square. So mv square divided by r. This is what here the relation between the Coulomb's law and the centripetal force. So these two forces are balancing with each other. Adakoskarane whatever the electrons are there, they are either falling inward or they are not falling outward here. They do force balance agodrinda adu circular motion anna maintain ಮಾಡುತ್ತೆ. Okay, then next. So next we will study about the atomic spectrum here, right? So in the atomic spectrum, so only I'll give you the main idea. That is, we have the 5 series of the spectrum here, that is called as Lyman series, Balmer series, Paschen series, Pfund series, and the bracket series, right? So about that we will discuss some points here. That is given by here. First we will see the expression for lambda. The wavelength of the given spectrum is given by 1 / lambda is equal to r. R is the Rydberg constant, 1 / n1 square minus 1 / n2 square. Yes, in some of the textbook n1 n2 is taken as n ಮತ್ತೆ m ಅಂತ ಕೂಡ ಹೇಳಿದ್ದಾರೆ. So as you wish, ನಿಮಗೆ ಯಾವುದು ಬೇಕೋ ಆ ತರ ತಗೊಳ್ಳಬಹುದು ನೀವು ಇಲ್ಲಿ. The Rydberg constant value you should know. ಇದು ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು, ಅವರೇನು ಕೊಡಲ್ಲ ಇದನ್ನ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ. It is 1.097 into 10 to the power of 7 per meter. This is Rydberg constant value. Okay, so as I told you, ನಾನು 5 series ಇದೆ ಅಂತ ಹೇಳಿದೆ ನಾನು ನಿಮಗೆ spectrum. So the first one is Lyman series. So for the Lyman series, the N1 is 1 and the N2 is taken the value from 2, 3, 4, 5 like that. Matte next, after line 1 it is a Balmer series. So Balmer series alli enagutte N1 is equal to 2 in the start agutte and N2 value 3 in the start agutte. It is 3, 4, 5. Then the next one is Lyman Balmer Passion series. So here the N1 value is 3 and the N2 value is taking from 4, 5, 6. Then next we have the bracket series. So for the bracket series, it is N1 is equal to 4, N2 is equal to 5 like that. Matte last alli P-fund series baratte. So according to P-fund series, it is N1 is equal to 5, matte N2 is equal to 6, 7 anta baratte. Hauda? So this is regarding the N1, N2 value. Matte idralli spectrum alli ನಾವು ಮತ್ತೆ ಏನು ನೆನಪಿಟ್ಕೋಬೇಕಾಗುತ್ತೆ ಅಂತಂದ್ರೆ here the Balmer series ಎದ್ರಲ್ಲಿ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ it falls in the visible region. ಮತ್ತೆ next Lyman series ultraviolet ಅಲ್ಲಿ ಬರುತ್ತೆ. It is falling in the ultraviolet region. Then the Passion and the bracket, it falls in the infrared region. So you should remember this. Namge objective alli ee part in the one question almost every year alla kelidare avaru. Okay, about the spectrum yav regional barutte athwa N1 N2 value, based on this at least one question is confirmed. Okay, let us go for the some of the formulas, then we can start with the question answers. Yes. So now Bohr's model prakara. So according to Bohr's postulate, the electrons are revolving in certain orbit. Yes, here the angular momentum of the electron is equal to line integral multiple of h upon 2 pi anta ಹೇಳ್ತಾರೆ. So here n is called as the principal quantum number. Here whatever the electrons are there, they are giving a transition. During that the energy released is given by h nu is equal to ei andre initial energy minus ef, that is the final energy. Yes, so some of the important formulas new book koಟ್ಟಿದ್ರೆ ನೀವು ಇದನ್ನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. The radius of the nth orbit is given by rn is equal to n square h square epsilon naught divided by pi m e square z anta barutte. This is the radius of the nth orbit. So ಇಲ್ಲಿ ನೋಡಿ h value Planck's constant ಹೌದಾ, ಕಡೆಗೆ epsilon naught permittivity, pi it is a constant, m mass of the electron, charge of the electron, ಎಲ್ಲಾ value ಕೂಡ constant ಇದೆ ಇಲ್ಲಿ. So therefore the radius of the nth orbit is also taken as 0.53 into bracket n square divided by z. So this formula is in terms of angstrom. So your radius is 0.53, it is a constant. So what I can say here, the radius is directly proportional to square of the n, that is the number of the atoms. Then next, it is inversely proportional to atomic number. Similarly, velocity of the nth orbit is given by, it is e square upon 2h epsilon naught into z divided by n. So this is velocity of the electron. Okay. Then third formula, the kinetic energy is given by, it is z e square divided by 8 pi epsilon naught into r. Okay. So this is kinetic energy. Then the potential energy is given by, it is z e square upon 4 pi epsilon naught into r. This is potential energy. Then one more, the time period of the nth orbit is given by, it is 2 pi rn upon vn. Yes. So these are the some of the important formulas for this lesson. Okay. So now we will go for the question answers. So first we will discuss the questions which we have for you. Then next we will discuss the previous year questions. Okay. So previous year questions anna kuda nodana. Like yesterday's class, last 10 minutes we will discuss the previous year questions. So yesterday some students asked me to send those previous year questions. So today what I'll do, I'll send yesterday's wave optics and today's atoms and tomorrow's nuclei chapter. So all the 3 chapters previous year questions I'll forward you in the group. Okay. So I'll forward it to sir. Sir will forward it, right? So let us see the first question. So here is our first question. So this is a little bit related to chemistry also. This topic chemistry li kuda kalitira ನೀವು atoms ಮತ್ತೆ nuclei anta. So here the first question is based on the electronic configuration. The atomic number of silicon is 14. Idantu ellargu gottide. That is its ground state electronic configuration is. So option A is 1s2, 2s2, 2p6, 3s2, 3p4. Option B 1s2, 2s2, 2p6, 3s2, 3p3. 1s2, 2s2, 2p6, 3s2, 3p2. And option D is 1s2, 2s2, 2p6, 3s2, 3p1. Yes. A, B, C, D. Yes. So almost everybody is knowing this answer. That is, it is option C. Nandish, Vidya, Damini, so all are giving answer. Asha. So it is option C. That is absolutely right. 1s2, 2s2, 2p6, 3s2 and 3p2. Next, what is the valence electron in alkali metals? So valence electron anta kaltidira ನೀವು. What is valence electrons? Valence electrons are nothing but what? The outermost cell electrons are called as valence electrons. Yes. So the valence electron in alkali metal, it is given by, it is F electron, P electron, S electron and the D electron. Correct. 100% right. That is C, option C, S electron. That's very good, students. So chemistry, I think you people are more interested in chemistry because everybody is answering. Very good. So next, of the following pair of spaces, which one will have the same electronic configuration for both members? So ಇಲ್ಲಿ pair of ಏನ್ ಹೇಳ್ತೀರಾ, pair of atoms ಅನ್ನ ಕೊಟ್ಟಿದ್ದಾರೆ. ಅದರಲ್ಲಿ ಯಾವ್ದ್ರದ್ದು ಸೇಮ್ electronic configuration ಇರುತ್ತೆ ಅಂತ ಕ್ವಶನ್ ಇದೆ. That is the lithium and the sodium, helium and the neon, hydrogen and the lithium, carbon and the nitrogen. Yes. Lohit is giving D. Harshita is saying D. Vidya is telling A. Shilpa, Rakshita, Padmashri, Saundarya. Yes. Option D is correct here. So ಅವ್ರು ಏನ್ ಕೇಳ್ತಿದ್ದಾರೆ, ಯಾವ ಪೇರ್ ಆಫ್ atoms ಇದ್ದು ಸೇಮ್ ಕಾನ್ಫಿಗರೇಷನ್ ಬರುತ್ತೆ ಅಂತ ಕ್ವಶನ್ ಇದೆ ಇಲ್ಲಿ. So no doubt whatever you people are giving, the option D is right. So we know that the carbon, it is giving you, that is, it is 6, right? And for nitrogen plus, so it is nitrogen, N plus is there. Therefore here also, even though it is a nitrogen ಅಷ್ಟೇ ಇದ್ರೆ ಅಲ್ಲಿ 7 ಅಂತ ಬರುತ್ತೆ, it is N plus. ಅವಾಗ ಏನಾಗುತ್ತೆ, it is giving out 1 electron. Therefore it is also becoming 6 here. Therefore here whatever the pair, that is option D is correct. Option D is correct here. Yes, right. Then the next question. So which of the following did Bohr use to explain his theory? So Bohr theory alli idralli yav concepts anna use ಮಾಡ್ತೀವಿ? Conservation of linear momentum, the quantization of angular momentum, conservation of quantum frequency, conservation of mass. Yes. Okay. So it is option C. That is, sorry, not option C, option B, that is quantization of angular momentum. Quantization of angular momentum. So option B is correct here. That is, it is nothing but the second postulate. How the so second postulate ಅಲ್ಲಿ ನಾವು ನೋಡ್ತೀವಿ, that is mvr is equal to nh upon 2 pi. So nh 2 pi ಏನಿದೆ ಇದೆಲ್ಲಾನು ಕಾನ್ಸ್ಟೆಂಟ್ ವ್ಯಾಲ್ಯೂ ಆಗುತ್ತೆ ಹೌದಾ. So the quantization of angular momentum, option B is correct here. Yes. Then the next question, according to Bohr's principle, what is the relation between the principal quantum number and the radius of the orbit? That is, r is proportional to n, r is proportional to n square, r is proportional to n. Actually here first option is it is 1 divided by n, and r is inversely proportional anta kodbekitta avralli. Okay. So here according to the option, the first one is it is 1 divided by, r is inversely proportional to n, r is inversely proportional to n square, r is proportional to n, r is proportional to n square. Yes, ನಾನು ನಿಮಗೆ ಈಗಷ್ಟೇ ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದ್ದೆ, ಅದರಲ್ಲಿ ನೀವು ನೋಡಿದ್ದೀರಾ. So according to that, your r is proportional to, yes, it is option C, it is proportional to n, it is proportional to n. Option C is correct. Correct. Next question. R is proportional to n. Then the next question is, the kinetic energy of alpha particle incident on the gold foil is doubled. So kinetic energy is getting doubled here. The distance of closest approach will also be doubled. So whether it is true or false. Yes, Harshita is right. Purvi, Varun, yes. Correct, correct. This option B is false. It false agate. Idu kinetic energy double adaga, the distance of closest approach, it is becoming half actually. Ad half agate. Now adana prove kuda madbodu. Aita. That is, when the kinetic energy is becoming double, the distance of closest approach is becoming half actually. It is not becoming double. Aita. So next question, based on the Bohr model, what is the minimum energy required to remove an electron from the ground state of beryllium atom? Yes. So for the beryllium, it is Z is equal to 4. How to do this? Here we have the simple formula to calculate the energy required. So the simplest formula is energy required is equal to, it is Z square into bracket 13.6 electron volt. Actually minus will come, but the answer will namge minus kottilla, so now we will minus tagolod beda. Here Z value is 4, so this is 4 into 13.6. What is the answer? 4 into 13.6. Yes, what is the answer here, students? Formula I told you what to do. Correct. Yes, Harshita, next. Damini, Shilpa. Okay, everybody is getting answer. That is option D is right. It is 217.6 electron volt. 217.6 electron volt. Okay. Next question. If an alpha particle collides head-on with a nucleus, what is its impact parameter? So ನೀವು ಇಲ್ಲಿ ಏನ್ ಮಾಡಿ ಇಂಪ್ಯಾಕ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಫಾರ್ಮುಲಾನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಆಲ್ರೆಡಿ ನಾನು ನಿಮಗೆ ಕೊಟ್ಟಿದ್ದೆ ಈಗಷ್ಟೇ. ಸೊ ದ ಇಂಪ್ಯಾಕ್ಟ್ ಪ್ಯಾರಾಮೀಟರ್ ಬಿ ಇಸ್ ಈಕ್ವಲ್ ಟು, ದಟ್ ಇಸ್ ಕೆ ಅಂತ ಇತ್ತಲ್ಲಿ, ದಟ್ ಕೆ ವ್ಯಾಲ್ಯೂ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ 1/4 by epsilon naught. It is Z E square cot of theta divided by 2 divided by kinetic energy. Yes. So here, what they are saying, it is a head-on collision. So if it is a head-on collision, can anyone tell me what is the theta value here? For head-on collision, what is the value of theta? Zero. Option is option we will see later. Whoa, yes. Head-on collision, the theta value is 180 degree. 180 degree baratte. So it is 180 divided by 2 andaga 90 to cot 90. So cot 90 what it is 0. Therefore the entire value becomes 0. Option A is the correct answer. Option A correct agide. Yes. So everybody is giving the same answer here. Let us go for the next question. In which of the following system will the radius of the first orbit n is equal to 1 be minimum? Doubly ionized lithium, singly ionized helium, deuterium atom, hydrogen atom. So nimge ಏನು ಗೊತ್ತಾಗಬೇಕು ಇಲ್ಲಿ, that is the radius is minimum ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಹೌದಾ, ರೇಡಿಯಸ್ ಮತ್ತೆ z ಅಥವಾ n ವ್ಯಾಲ್ಯೂ ರಿಲೇಶನ್ ಗೊತ್ತಿದ್ರೆ ನೀವು ಇದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೋಬಹುದಾಗಿದೆ. ಆಪ್ಷನ್ ಡಿ. So some are giving option D, C, A, ಎಲ್ಲ ಆನ್ಸರ್ ಕೂಡ ಬರ್ತಾ ಇದೆ ಇಲ್ಲಿ. So correct answer ಅನ್ನು ನೋಡೋಣ. That is here the radius is directly proportional to n square upon z. Yes. Okay. So ಇಲ್ಲಿ ನೋಡಿ n is equal to 1 ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು. n is equal to 1 ಅಂದಾಗ ಏನಾಗುತ್ತೆ? It is proportional to 1 divided by z ಅಂತ ಆಯ್ತು. So what is the radius is minimum. ರೇಡಿಯಸ್ ಮಿನಿಮಮ್ ಇರ್ಬೇಕಾದ್ರೆ ನಿಮಗೆ z ವ್ಯಾಲ್ಯೂ ಏನಿರ್ಬೇಕಾಗತ್ತೆ? ಮ್ಯಾಕ್ಸಿಮಮ್ ಇರ್ಬೇಕಾಗತ್ತೆ. ಸೊ ನಾವ್ ಯು ಥಿಂಕ್ ಅಂಡ್ ಟೆಲ್ ವಿಚ್ ವಿಲ್ ಬಿ ದ ಆನ್ಸರ್. z ಎದರಲ್ಲಿ ಮ್ಯಾಕ್ಸಿಮಮ್ ಬರ್ಬೋದು ಅಂತ? ಹೀಲಿಯಂ, ಡ್ಯೂಟೇರಿಯಂ, ಹೈಡ್ರೋಜನ್, ಲಿಥಿಯಂ. Yes, correct. So that is option A. Option A is right. That is the doubly ionized lithium. Because in all the options, ಇಲ್ಲಿ ಏನು options ಕೊಟ್ಟಿದ್ದಾರೆ, for deuterium the z value is 1. For hydrogen the z value is 1. Then next for the lithium it is 3, and for the deuterium which is remaining, that is single ionized helium, it is 2. Okay, so lithium ಗೆ maximum ಬರುತ್ತೆ z, ಅದಕ್ಕೆ r value ಕಡಿಮೆ ಆಗುತ್ತೆ. Next question. So here is our next question, that is an alpha particle of energy 10 mega electron volt is scattered through 180 degree by a fixed uranium nucleus. So here we have the alpha particle and the energy of the alpha particle is 10 mega electron volt. Okay, it is scattering through an angle of 180 degree by a fixed uranium nucleus. Calculate the order of distance of closest approach. So distance of closest approach ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ. That is nothing but the r value. Option B, yes. Yes, Harshi, that is right. Option B correct agide. So let us see how to calculate. That is kinetic energy is equal to potential energy. The kinetic energy is equal to potential energy. Okay, so let us substitute the formula and simplify this. ನಾನು ನಿಮಗೆ ಫಸ್ಟ್ ನೇ ಒಂದು ಫಾರ್ಮುಲಾ ಕೊಟ್ಟಿದ್ದೆ. That is here the kinetic energy half mv square is equal to Coulomb's law, that is k into e square it is. ಹೌದಾ, q1 into q2 ಬರುತ್ತೆ. So for alpha particle the q1 value is 2e. Then for the uranium it is 92 into e. It is 92 into e divided by it is r, divided by r. I require only r here. ನನಗೆ r ಬೇಕಾಗಿದೆ ಇಲ್ಲಿ. Therefore r is equal to, so r is equal to your k value is 9 into 10 raised to 9 ಅಂತ ಬಂತು. 2 into 92 into e. Then kinetic energy, that is the energy is given as 10 mega electron volt, 10 into 10 raised to 6. Yes, so substitute, simplify, you will get option B. ನಮ್ಗೆ ಅದೇನ್ ಆನ್ಸರ್ ಬರುತ್ತೆ ಅಂತ ಕೇಳಿಲ್ಲ, ಕೇವಲ ಇಲ್ಲಿ ಅವರು ಪವರ್ ಅನ್ನ ಕೇಳಿದ್ದಾರೆ. ದಟ್ ಇಸ್ 10 to the power of -12. All the values are constant and the kinetic energy value is, or the energy value is given. It is 10 mega electron volt. That is 10 into 10⁻⁻6. Okay. Okay. So the next question is, which source is associated with a line emission spectrum? So in case of line emission spectrum, which source is associated with that? Electric fire, neon street sign, red traffic light, and the sun. Yes, which option is right? Red traffic light? No, it is option B. Here some students have given option B. Option B is right. That is the neon street sign. Neon street sign. This correct. Okay. Then our next question. So here is our next question. That is, according to uncertainty principle, for an electron, time measurement will become uncertain if which of the following is measured with high certainty? Okay, can anyone tell me which is that uncertainty principle was given by whom? Name a scientist who proposed this uncertainty principle. Yes, students, who proposed uncertainty principle? Yes, Heisenberg was proposed this uncertainty principle. Heisenberg will propose the uncertainty principle. So according to his principle, which two quantities we cannot find simultaneously? So according to Heisenberg, we cannot find two quantities simultaneously. Which are the two quantities? That is, see here the electrons are revolving in an orbit. So there the position, and when it is moving, it is having some momentum. So the momentum and the position cannot be determined simultaneously. This was the Heisenberg uncertainty principle. But here what they are asking, the time measurement will become uncertain if which of the following is measured with high certainty. That is option A is right here. That is the energy. Okay, energy correct agide. Option A. Then our next question, the size of the atom is proportional to which of the following? The size of the atom is proportional to which of the following? Option A is A, option B is A to the power 1/3, option B is A to the power 2/3, and option D is A to the power 1/3. Yes. Nandish is saying B. Damini is saying B. Yes. Option B is correct. That is A to the power 1/3. A to the power 1/3. Okay. Yes. Calculate the ratio of kinetic energy for the N is equal to 2. electron for the lithium atom to that of beryllium ion. So here options, it should be 9:16, 3:4, 1 or 1:2. You're calculating or you're just giving the answers randomly? So option A is right, that is 9:16. Then the next question. Okay, the next question is the Bohr model of atoms uses Einstein's photoelectric equation. Yes, whether it is true or false. The Bohr model of atoms uses Einstein's photoelectric equation. It is false or it is true? Yes, it is true. Here the Bohr model will use Einstein's photoelectric equation. So that is the energy relation he will use there. Okay, Bohr ಏನ್ ಮಾಡ್ತಾನೆ Einstein ಏನ್ theory ಇದೆ ಅದನ್ನ ಸ್ವಲ್ಪ ಇಲ್ಲಿ adopt ಮಾಡಿ he will give his second postulate or the second assumption here. Okay, so the next question is what is the ratio of minimum to maximum wavelength in the Balmer series? So ನಾನು ನಿಮಗೆ ಮೊದಲೇ ಹೇಳಿದ್ದೆ ಸ್ಟೂಡೆಂಟ್ಸ್ ಈ ತರ ಕ್ವೆಶ್ಚನ್ಸ್ ನಮಗೆ ಬರುತ್ತೆ ಆಯ್ತಾ. So here the ratio of minimum and maximum wavelength in the Balmer series he is asking. So let us see the 1 by lambda, the wavelength equation is equal to the Rydberg constant into bracket 1 upon n1 square minus 1 upon n2 square. So minimum ಮತ್ತೆ maximum ಅಂದಾಗ n1 n2 value ಏನಂತ ಬರುತ್ತೆ ಇಲ್ಲಿ? Here when you consider it is a Balmer series, n1 is equal to ಎಷ್ಟು ಬರುತ್ತೆ ಹೇಳಿ? What is the value of n1? Don't give only answers. Yes, Rakshita is right. That is Nandish. So n1 is equal to n baratte. That is, it will be 2. Maximum antandaga n baratte. N2 is equal to, it is infinity. Yes, very good. That is, it is n2 is equal to infinity. Maximum anta ಹೇಳ್ತಿದ್ದಾರೆ ಅವರು. That is the first and the second anta ಹೇಳ್ತಿಲ್ಲ. So first second ಅಂದಾಗ ಏನ್ ಬರುತ್ತೆ? n1 is equal to 2 ಬರುತ್ತೆ, n2 is equal to 3 ಅಂತ ಬರುತ್ತೆ. So minimum maximum ಅಂದಾಗ minimum ಕಡಿಮೆ ವ್ಯಾಲ್ಯೂ ಮತ್ತೆ ಅಗ್ದಿ ಯಾವುದು ಜಾಸ್ತಿ ವ್ಯಾಲ್ಯೂ ಇದೆ ಅದು ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬೇಕಾಗುತ್ತೆ ಆಯ್ತಾ. So let us substitute here, which is equal to r into bracket 1 upon 2 square minus 1 upon n2 is our, for minimum it is 3 square. Then similarly for the maximum it is r into bracket 1 upon 2 square minus 1 upon infinity. So this is the ratio of what? Lambda minimum to the lambda maximum. Lambda minimum to the lambda maximum. So here if you simplify, which option you will get? Yes, very good. It is option A, 5:9. It is option A, 5:9. The next question. The energy of characteristic X-ray is a consequence of which of the following? So the energy of characteristic of X-ray, it is consequence of what? The energy of the projectile electron, the thermal energy of the target, transition in target atoms, or the temperature. The energy of characteristic X-ray is a consequence of which of the following? Yes. So it is option C, transition in the target atoms. It is the option C, transition atoms, that is the target atoms. Option C is correct. Okay. So next question. Find out the minimum energy required to take out the only one electron from the ground state of lithium. So how to calculate this? We need to calculate the minimum energy required to take out the only one electron. ಕೇವಲ ಒಂದೇ electron ಅನ್ನ ground state ಇಂದ ತೆಗಿಬೇಕಾದ್ರೆ ಎಷ್ಟು energy ಬೇಕಾಗುತ್ತೆ? That too for the lithium atom. It is B 122.4 or 25.3. Yes. So it is B 122.4. It is right. So ಯಾರಿಗೆ ಗೊತ್ತಿಲ್ಲ ಅವರಿಗೆ ನಾನು ಇಲ್ಲಿ ಸೊಲ್ಯೂಷನ್ ಹಿಂಟ್ ಕೊಡ್ತೀನಿ. ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಯಾವ ತರ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ it is the ionization energy they are asking. ಹೌದಾ? It is 13.6 into Z square into bracket 1 upon N1 square minus 1 upon N2 square. Yes, this is the energy is equal to. So which is equal to 13.6 into Z value. Lithium rest baratte 3 baratte. So it is 3 square into bracket. So here you can substitute the value here. It is 1 upon 1 square minus 1 upon infinity. Okay, so here if you simplify this, we will get it as 122.4 electron volt. Options B is correct. Yes. So last one more question we will discuss. Then after that we will go for the previous year questions. What is the energy required to ionize an hydrogen atom from the third excited state if ground state ionization energy of hydrogen is 13.6 electron volt? So you solve and tell me this answer, then I'll give you the next year questions. So this is for you. What is the energy required to ionize an hydrogen atom from the third excited state if the ground state ionization energy of hydrogen is 13.6 electron volt? So Shilpa is giving option A. One 1.5 electron volt or 3.4 electron volt? Which one is right? Yes. So here option A is correct. Option A is correct here. Okay. That is 1.5 electron volt. Now let us go for the previous year questions. So first I have the question of the year 2014. So the question is, which of the series of hydrogen spectrum is in the visible region? Visible region ಅಲ್ಲಿ ಯಾವುದು ಸ್ಪೆಕ್ಟ್ರಮ್ ಬರುತ್ತೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಇಲ್ಲಿ. So here the option A is Lyman series, option B is Balmer series, option C is Passion series, and option D is Brackett series. Yes. Correct. That is Balmer series. How? So that is the Balmer series which will lie in the visible region. This is 2014 question. Then next I have the question from 2018. So 2018 ಅಲ್ಲಿ 3 question ಕೇಳಿದ್ದಾರೆ ಅವರು. So first I'll solve that, then 2015 question ಕೂಡ ಇದೆ. 2015 ಅದ್ದು ಹೇಳ್ತೀನಿ. So now 2018 question. The question is the period of revolution, or you can say the time period of revolution for an electron in the ground state of hydrogen is T. So for the hydrogen, the time period of revolution in the ground state is T. This is one part. The period of revolution of the electron in the first excited state is, the period of revolution of the electron in the first excited state is, option A is 2T, option B is 4T, option C is 6T, and option D is 8T. Question ಅರ್ಥ ಆಯ್ತಾ? ಮತ್ತೊಂದ್ಸಲಿ ರಿಪೀಟ್ ಮಾಡ್ಬೇಕಾ? Should I repeat the question or you have understood the question? Okay, the question is, the period of revolution of an electron in the ground state, the period of revolution of electron in the ground state of hydrogen atom is T, capital T, okay? The period of revolution of the electron in the first excited state is, in the first excited state, ground state alli time period T ide, excited state alli ಏನು ಬರುತ್ತೆ? In the first excited state. So in the ground state, the time period of revolution is T for the electron. In the first excited state, what is the time period value? Simple words. Yes, it is option D. It is right. So that is, it is 8T students. 8T ಬರುತ್ತೆ ಆಯ್ತಾ? ಹೇಗೆ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ, you can calculate your time period and the whatever the excited state is there. Yes. So time period T is directly proportional to your n cube. It is directly proportional to your n cube. So here n is equal to, here the n is equal to, it is the 2. It is 2. So it is 2 cube it is. So 2 cube ಅಂತಂದ್ರೆ ಎಷ್ಟು ಬಂತು? 8 ಅಂತ ಬರುತ್ತೆ. Therefore option D is correct. Option D is correct. This is asked in 2018 ಆಯ್ತಾ? Then 2016 question. So the question is, when an electron jumps from n is equal to 4 to n is equal to 1. When an electron jumps from n is equal to 4 to n is equal to 1, the angular momentum of electron changes by, angular momentum of the electron changes by, when an electron jumps from n is equal to 4 to n is equal to 1, the angular momentum of electron changes by. So options h upon 2 pi, 2h upon 2 pi, 3h upon 2 pi, ಅಥವಾ 4h upon 2 pi. I hope the question is clear to you. So the angular momentum when it is giving a transition from n is equal to 4 to n is equal to 1. So here the change in the angular momentum is given by, I'll tell you the formula. It is n1 minus n2 into h upon 2 pi. Aita, idu formula baratte. So n1 is 4, n2 is 1 into h upon 2 pi. In baratte answer. 3h upon 2 pi. Option C is correct. I hope the question is clear to you and the solution is also clear to you. This is asked in 2016. Then one more question from the 2018 again. So the question is, the total energy of an electron revolving in the second orbit of hydrogen is. The total energy of the electron revolving in the second orbit of the hydrogen is. Options 13.6, minus 1.5, 1, minus 13.4. Idella electron volt ide, and option D is 0. So I'll repeat the question. The total energy of an electron revolving in the second orbit of hydrogen atom is. Yes, Rakshita Kumar. So they are saying it option C. Yes, option C is right. Minus 3.4 correct agide. So yari gottilla illi nodi. The energy is given by minus 13.6 z square upon n square. Hauda? So z is equal to 1. Yakandre hydrogen atom anta helidare avaru illi. So n is equal to 2 agatte. It is minus 13.6 upon n square is 2 square is 4. Hauda? Yes bantu. Minus 3.4 option C is correct here. Okay. So this is 2018 question. Then next, so one more question is asked in the 2018. So minimum 2, maximum 3 questions are fixed from this 2017 question. I'll read out. So question enappa antandre, the mass defect of helium 24 is 0.03 U. The binding energy per nucleon of helium in terms of mega electron volt is. Options 6.98, option B 27.93, option D 2.79, option D is 69.82. So I'll repeat the question. The mass defect of helium-24 is 0.03 U. The binding energy per nucleon. Yes, anybody is getting the answer? A you are getting. A baratta, B baratta. So here the solution is the mass defect. ಎಷ್ಟು ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ 0.03 U ಅಂತ ಇದೆ. Then the binding energy of the helium is equal to, it is delta M into 931 mega electron volt. Hauda? So this is 0.03 into 931, which is equal to, it is 27.93 mega electron volt. Hauda? This is energy. But what they are asking, the binding energy per nucleon anta keltidare illi. Hauda? So the binding energy per nucleon andag enagatte, idu divided by n agatte. So your n value is how much here? The n value is, it is for the helium, it is 4. Adakke ಎಷ್ಟು ಬರುತ್ತೆ? Option A, that is 6.98. It is correct. The 6.98 is right. Option A is correct. Very good, students. So again, some 4-5 questions are there, as I told you already. So yesterday's wave optics, today's atoms, and tomorrow's nuclei. Ella chapter idu previous year questions anna nanu nimge forward ಮಾಡ್ತೀನಿ. Okay. So let us continue it in tomorrow's class. Thank you. Have a good day.